Yo, what's up, geometry students? Mr. Besser coming at you. We are going to be talking about scaling. The idea that, you take previously in the previous unit, we were looking at the comparison of numbers and we were talking about from 2 to 6, the change was 4. Yes, that's how you find change. You subtract the numbers or think about addition. But now we're going to talk about like relative sizes and we're going to keep things relatively proportional. So, like, instead of 2 to 6 is plus 4, I'm going to say 2 to 6 is times 3. Or we're going to take the number 6 divided by 2 to figure out how many times the size is. This will help keep the same shape, keep things proportional. The most easiest example we talked about in class, which is a question, is like if I give a mini quiz worth 50 versus a normal entrance ticket of 100, if Miss Srinivasan has more normal entrance tickets of 10 points, it's not that we're going to subtract 50 points from hers and say her quizzes should be worth negative 40. That doesn't make sense. To keep things relatively the same, we're going to think about the relative size, the ratio. We're going to say it's half the size. So 50 divided by 100 is a half. Or her entrance tickets should be worth 5 points so that things are relatively the same. And that's what we see here. We have like different, for the rest of the homework, is like different size things, but we want to keep everything in proportion. So we need to figure out how many times the size. We could see like from 2 to 24. I'm not going to say that's plus 22. No, I say that that's times 12. Now, how do you get that? You should probably have a calculator ready. If you have Desmos, it's always helpful. You can divide to figure out how many times the size something is compared to something else. So divided by 24 divided by 2 is times 12, which means all I have to do is 3 times 12. And I get 36. And guess what, guys? You don't have to set up proportions and solve them if you don't have to. It's like you don't have to. You could have done something else. You could have said, what about this length 2 to this length 3? Well, you can see 3 is 1.5 times the size of 2. I could have also done 24 times 1.5, and I've also gotten 36. So just making sure you understand there are multiple ways to get the value, but you don't really have to set up proportions as long as you understand the relative size. Okay, so here we have a mirror. This is what we're going to be doing in class on Wednesday out and around campus. And what we see is that we have two similar triangles. Things have to be proportional, where you have a height versus a length, and this height versus this length. These angles are going to be the same, which means these angles are going to be the same. And since they're 90-degree angles, we have proportionality. We have like the same exact shape, just different sizes. And you could just work with 45 and 7.5. 45 is 6 times the size of 7.5. So that means this height must be 36 because I'm going to take 6 and multiply by 6. So I can just say 6 times 6. That's one way to get my answer. What's another way to get my answer? Well, 6 to 7.5. You can do 7.5 to 6. And you're like 1.25. So that means 6 times 1.25 is 7.5. Or 7.25 divided by 1.25 is 6. I could also take 45 and divide it by 1.25, and I'd also get 36. So it's like making sure we see there's multiple ways. I want us to be able to get answers different ways using different numbers, different proportionalities, and know that we would get the same answer. Okay. The next situation involves us understanding the two different triangles. We have the dude who's 5 feet tall, who's got a shadow length of 8 feet, and then the tree all the way to the end of the shadow is your other triangle, which has a total length of 24. They give you that total length of 4, and we're trying to find the height of the tree. Well, we can kind of see the relative size. You got that 8 that's going to go with that 24. 24 divided by 8 is 3. So we got this times 3. Or you could say 5 to 8. 8 times 5, or 8 divided by 5, is 1.6. So you could either say the entire triangle times 3, or the small length to the larger length is times 1.6, which means you could either divide by 1.6 to get this number, or you could take 5 and multiply by 3. So 5 times 3 is one way to get the answer, 15, or 24 divided by 1.6 is another way to get that answer, 15. Cool. Okay. We got this length 8, this length 10, this length 20, 45. We're trying to find this length of this pond. I wonder if this is actual surveillance. I bet you this is. Kind of like set up a camera here and figure out an angle and set up a camera here, figure out an angle, and then boom, like if you find that intersection there, I guess you could mark. I don't know if this is what you would do, but anyways, you could kind of see your two triangles. You have this smaller triangle with a length of 8 and 10. You could compare those two lengths if you want to. And then you have, I'm going to kind of orient it differently, the larger triangle that has a length of x that would go with the length of 8, and the length of 45 that would go with the length of 10. Now you could either compare the lengths within the triangles or compare the two triangles overall. So you could say the bigger triangle, 45 with the length 45, would be 4.5 times the size of the smaller triangle. Cool, so that's one way to get x. You could take 8 and multiply by 4.5. What's another way to get x is you could compare the number 8 and 10. And you could say 10 is 1.25 times the size of 8, which means 8 is divided by, or 10 divided by 1.25, it will be 8. I could take 45 and divide it by 1.25 to also get my answer. 8 times 4.5 is 36, and then 45 divided by 1.25 is also 36. Cool. We did this exact same problem in the homework, in the notes, so hopefully you paid attention to it. You could either compare the length 6 to 8, or you could say the smaller object with a length 2 would go to the big object with a length 6. You could see that that length is 3 times the size. 6 divided by 2 is 3. You could also compare 8 and 6, and you got 1.333 or 4/3. So you can either say 6 times 4/3 is 8, or 8 divided by 4/3, just times 3/4, is 6. Or you could say the small object to the big object is times 3. The big object to the small object would be divided by 3. I think this is the easiest way to do it. So 1 times 3 is 3, so x is 3. And then 8 divided by 3 is y, so y is 8/3. What's another way to do it? You could say 2 times 4/3 will be y, and that's 8/3. And what's another way to find x? You could see the small object, you have 2 to 1. So you can either multiply by 2 to get the bigger side or divide by 2 to get the smaller side. So there's another way. 6 divided by 2 gives you that x of 3. All right. Again, you could just look at relative sizes within the triangle, or you could just look at overall the size of the one triangle to the other. So I could see the bigger triangle with the length 9, y, and x. That length 9 would correspond with the length of 6 in the other triangle. So I got that 6 to 9, that's 1.5 times the size. So I can either multiply by 1.5 or divide by 1.5. think it's easy enough to just multiply by 1.5. So I got x is 12 times 1.5. I got y is 9 times 1.5. What else could you have done? You could have also looked at the relative sizes within the triangle. So you can compare 6 to 9 within the small triangle and say that's 1.5. And you can say, okay, yeah, that's another way to do it. It really ends up with the same calculation. You could do 6 to 12. That's a times 2. So that 9 to x in the big triangle, 9 times 2 will be the same as the 12 times 1.5. You could get that x is 18. You could look at 12 to 9. So 9 to 12 is 0.75. So times 0.75, or you go 12 to 9 is 1.333. So that's times 4/3. You can multiply by 4/3 or divide by 4/3. You can multiply by 3/4. There's different ways to use your calculations. And you'll get your answer 18 for x. And then you get your answer 13.5 for y. Cool. What if it's not just x? What if it's like x minus something or y minus something? Well, let's just like do it the easy way. My easy way is I think is the relative size of the shapes. So like we see these quadrilaterals, you can see the 8 goes to the 10. So how many times bigger is the 10 to the 8? 1.25 times bigger. Well, that sets up some equations where 1.25 times x minus 2 will equal 15. Okay, I can solve that equation. 2 times 1.25 equals y minus 3. Okay, I can solve that equation. As long as you know how to solve equations, you're good. You don't really have to use a proportion. So I got 1.25 times x, and then 1.525 times 2 is negative 2.5. So I got 1.25x minus 2.5 equals 15. I'm going to add 2.5. I have 1.25x equals 17.5. I'll then take 17.5 and divide it by 1.25 to get 14. Great. 2 times 1.25 is 2.5 equals y minus 3. Add 3, y equals 5.5. So I got 14 and 5.5. Are there other ways to get those answers? Yes. We could have looked within this, say 15 to 10 is 1.5 times the size, which means 8 to x plus 2 is 1.5 times the size. I would have gotten x minus 2 equals 1.5 times 8. Sometimes like there's an easier one out there. You don't have to do the same things. And you get x minus 2 equals 12. X equals 14. So just like you can look at relative sizes within the object, or you can look at the relative size comparing the two objects. Cool. Everything has to be proportional. And you could have done that with y as well. And then we go to the last questions. These questions we did on our notes. The last 2 questions on our notes. These questions we did not. So the key to these questions is to really separate the 2 triangles and make sure you understand the 2 triangles and their relative lengths. So there is a small inner triangle. In this question would be AGH. I'm going to write down the side lengths. It's a 3, 4, 5, which means it must be a right triangle. But we're not going to use that to our advantage. So AGH 3, 5, 4. And then the other bigger triangle is ABC. Now, here's where it's crucial. AB is x plus 3. AC is 4 plus x plus 5. So that's x plus 9. And then BC, I have no idea what it is. Now, this is a great problem because you don't know the relative size of the bigger triangle compared to the smaller triangle. But you do know the relative size of one side length to the other. So 3 to 4 is 4/3 times the size, which means x plus 3 to x plus 9 would be 4/3 times the size. This is how we'd set this up. 4/3 times x plus 3 will have to equal x plus 9. Now you got to figure out what 4/3 times x plus 3 is. Well, distribute. I get 4/3 x plus, what's 4/3 times 3? You should know that it's just 4, but if you need to do it, you can. It's just 4. Now, what do? I'm going to subtract an x from 4/3 x. If you need to do 4/3 minus 1 to know that that's 1/3, great. But you should know that 3/3 taken away from 4/3 is 1/3. Then I'm going to subtract 4 to get 5. I'm going to multiply by 3 to get 15. And that's how we find x. And that's a really, really good question because you don't know the relative size. Now you do. If x is 15, this side length AB is 18. This side length AC is 24. Which means this triangle is 6 times the size of that triangle, which means BC is going to be the length of 30. Cool. Good question. Next question, we have our side lengths of x and 6 in our smaller inner triangle, which I'm going to kind of sketch down first and understand x and 6. And then my larger outer triangle will have lengths of 20 and 15. I'm going to sketch down that larger triangle with lengths 20 that would correspond with x and 15 that would correspond with 6. Now this is easy enough to see that 6 to 15, 15 divided by 6 is 2.5 times the size. So we got to times 2.5 to get the bigger one, which means we divide by 2.5 from the bigger one to the smaller one. So I'm going to do 20 divided by 2.5 and get my answer 8. Cool. Next question, we got our smaller and our bigger triangle. Let's see if you can figure it out yourselves. We got this 10, 12, 8 smaller triangle. And then the bigger triangle. Yikes. We'll have lengths 16, 8 plus x, and y. Ugh. I'm trying to make it the same like shape, but it's hard to do. Whatever.
Ready?
Oh, I can't.
Ready?
Can't make it look the same shape. Close enough. This bigger length is 16. This length is 8 plus x. This length is y. So we can see which sides correspond to each other. We can see that the bigger triangle is 1.6 times the smaller triangle. Or we can see the relative sides within the shapes. You got like 8 to 10, you got 10 to 12, so you got 10 eighths, you got 12 tenths. Different ways to do it, different ways to get the right answer. I think the easiest way for this problem is just to go small to big. So we got 8 times 1.6 is 8 plus x. Yeah, x plus 8. So 8 times 1.6 is 12.8. So I got 12.8 equals x plus 6. Sorry, 12.8 equals x plus 8. So subtract 8 from 12.8, and I get 4.8 is x. And then I got 12 times 1.6 is y. Which is 19.2. The last two questions we did in the notes, I'm not going to do it again. I kind of want to show you this question though. It's like sometimes, guys, you just have to pay attention, and some things are really easy to find. Like you got x 4 and 4, you got x plus 4, 5, and 4 plus y, or y plus 4. Look at how these side lengths are the exact same. That means these side lengths have to be the exact same. Like 5 equals 4 plus y. Y is 1. That's so easily done. Now, how do we find the other one? Well, we have to use the fact that this triangle is 1.25 times the size, which is how we do 1.25 times this x will equal this x plus 4. And we get 0.25 equals x, 2.25x equals 4, x equals 16. And this one you could skip just because it works out before.
All right, thanks.
All right. Peace.